Okay, the next example here from the back. Squirrels on a horizontal branch. Remember horizontal? This way. There's the squirrel walking. Looks down at the leaf on the ground with an angle of depression of 50 degrees. Continues to walk 2 meters further and then looks down and we have a new angle of depression of 62 degrees. How high is the squirrel above the ground? Correct answer to about 1 decimal place. Assume that both the positions, the squirrel is the same side of the leaf, and we're going to say that their eyes are right down by their feet. They're crawling on all fours. So let's draw a picture to try and figure out what we're trying to figure out. There's our branch. We got our squirrel. On our branch. And we've got there looking down at an angle of depression 50 degrees. They walk 2 meters along the branch. And now they look down at an angle of depression of 62 degrees. If our leaf is on the ground there, there we go. Now we don't know how far this is, but the leaf straight up to the branch would make a 90. The leaf on the ground, whether the ground is flat or not, would also make a 90. So what do we got? Essentially, from our drawing, we have two triangles together. There's a 90 there, and we have another irregular triangle. 50 degrees, 62 degrees, with our 2 meters. So if I were to ask you, what do we need to actually find? We need to find the height above the ground. We need to find x. From this triangle, to find x, if we look at that, we have a right angle triangle. We have one thing we know, when we don't. If we had another side, then we'd be able to find that using SOHCAHTOA. So we need to find one more of the sides. If we look at the big triangle, we have an angle. We don't have a full length here. If we had that full length, we could use SOHCAHTOA to find that side. So if we break it down, our end goal to find the height above the ground, we need to find another side. Now this side here is shared between both triangles. So if we look at that triangle and we start saying, how can we get this side, non-right angle triangle, sine law or cosine law? So let's think about that. We could find a matching side, a matching pair, or a matching pair. But we only have one angle. We want that side, or we want this large side. We have that side, we don't have that angle. But that gives us the hint. So step one, let's find the angles in there. So I'm going to label them so we know. We're going to call this angle A. I'm going to call that angle B. So angle A, there's a straight line and goes through. Supplementary angle theorem. So remember that angle A, and it should be the capital since it's a vertex, is going to be 180 degrees minus that 62, which gives us 118 degrees right there. Now we want the angle on the opposite side of the triangle is 2 meters, so that we have one of our matching pairs for sine law. So step 2, we're going to look specifically now at that triangle. We've got 1, 2, we can find the third. The rule now, sum of the angles of the triangle theorem. I'm going to call that, it's already the angle B. So angle B is going to be 180 degrees minus angle A, 118, and minus the 50. And that tells us that angle B, 12 degrees. Okay. So now if we look at that sort of idea, and just specifically this triangle, that's not 90, remember, that's 118, here's 50, and we just found this one is 12. We have our 2 meters, we have side A, and because these were A and B, I'm going to call this side C. So I can use sine law now because I have one set of matching pairs here, and then I can either find this one and look at this as a large triangle, or I can find side C and look at that as a small triangle. So again, common side is the first thing I said, but I might look at this as a large triangle. So I'm going to use that one. We should get the same answer, close enough, depending on how you rounded, if we went the other way. So side A over sine of 118 is going to equal side B over sine of 12 degrees. A divided by that number, so to isolate our variable, we're going to multiply the entire left side by sine 118 degrees, which means we're going to multiply the entire right side by sine 118 degrees. Side A is 2 times sine 118 all over sine 12 degrees. Type that in your calculator, and we got 8.49, which rounded to 1 decimal place, it's going to be 8.5 meters. Now that, again, is from the squirrel's eye in its original position to the leaf. It's not the height. But now we have that right angle triangle, the large right angle triangle. So now that we have that, we can look at a large triangle as a whole. We have a 50 degrees in the corner. We have our 2 meters from there to there, irrelevant right now, but we just found 8.5 right there. Now when we look at this right angle triangle, we have an angle, we have a side, we need to find another side. We'll go back to our toolbox, right angle triangles, Pythagorean theorem, or SOHCAHTOA. So if this is a side we need to find, but we're looking from that angle, from that corner. So there's the 90, this is the hypotenuse, this is the opposite side, and this whole thing is the adjacent side. So done in purple, not to be confused with side A or vertex A from our first triangle. There we go. So there's the angle we need, H. We got to find O. SOHCAHTOA, I'm going to use sine. Sine of 50 degrees is equal to opposite over hypotenuse. Rearrange for our unknown. Multiply the right by 8.5. Math is so fair. Whatever we do to the right, we do to the left. I would usually just have my answer here. just like here, from this step, I go right to my answer. This is just remember to show you the rearrange. Kind of running out of space, so I'm going to do that. No, let's show you. If you have a scientific calculator again, you write that, type it right into your calculator right away. Certain phones or calculator programs on phones, you got to do it backwards. Enter that all in. We got 6.51, round to 1 decimal place, 6.5. There's our final answer. Therefore, the squirrel is 6.5 meters off the ground. Putting everything we know together. Give it a go.